x, the length x here of the small triangle EFD. But before we go there, we have to find first the hypotenuse AC. Okay, so let me find here the hypotenuse AC. But if we are looking here with the trigonometric ratio, we have here, this is the opposite of the angle, so we can use the angle sine. Sine A is equal with the opposite divided by hypotenuse. In our case here, sine 23 degree is equal with a 43.6 divided by hypotenuse, which is hypotenuse H, which is a AC, segment AC. And if we want here to find the hypotenuse AC, is equal with a 43.6 divided by sine of a 23 degree. But sine of 23 degree is equal with 0.39 if we are rounded to the two decimal places, 0.39, and the hypotenuse AC, or the segment AC, when we are dividing everything, is going to be equal with 111.79 units. But now AC, we're looking here, is equal with CE plus ED plus DA. So AC is equal with CE plus ED plus DA. But if we are looking here, for instance, those all three segments here are congruent. It means are equal, in other words, all these measurements are equal. And CE is equal with ED and is equal with DA. In other words, AC is equal with 3 is equal with 3 ED. Okay, so let me write here 3 ED. If we are dividing everything by 3, it implies ED is equal with AC divided by 3. But AC here we see is 111.79 units, and if we divide by 3, it turns out, so we can calculate it in a calculator, is 37.69 units. But now, if we are looking at the small triangle, is EDF. And to find angle X, we have this angle 35.6, but the angle is the opposite of the X. So we can use the trigonometric ratio of the sine X, or in other words, the sine of 35.6 degree. And the sine of a 35.6 degree is equal with X divided by ED. And this implies so X is equal with ED times sine of 35.6 degree. So X is equal ED, we already have 37.69, and here we have a times sine of 35.6 degree. When we are calculating everything in a calculator, X turns out to be 21.94 units. 21.94 units. And we found the value of X, which X is equal with 21.94.